Good morning students, welcome back to the class. I hope you all are fine. So in the previous class we have done exercise 65 and in this class we will be doing exercise 66 and 67 both. Okay, so let's begin. So before going to exercise 66, first we will learn some important things. First we will learn the definition of parallel lines. Okay, so first I am drawing here two parallel lines, then I will tell you. So these two lines are called parallel lines because they cannot, if we extend both of them, they cannot intersect each other. Okay, and in each and every point the distance between them is always the same. Okay, so that's why these two lines cannot intersect each other and these lines are called parallel lines, parallel to each other. Okay, similarly these two lines are also parallel lines. Okay, these two lines are also parallel lines because the same case here and here also, they cannot intersect each other if we extend them, both of them. Okay, now next definition we will learn is about the perpendicular lines. So what are perpendicular lines? You can see in these all cases, all the lines are intersecting each other. Okay, that means they are meeting at a point. They are intersecting each other and not only intersecting, they are making a 90-degree angle. Okay, here also 90-degree angle they are making. So, if two lines are intersecting each other at a 90-degree angle, then these two lines are called perpendicular lines. Okay, so this type of lines we will learn in this exercise, that which are perpendicular lines and which are parallel lines. Parallel lines are two lines, not only two lines, more than two lines can also be parallel to each other. That means lines which cannot intersect each other and lines which in each and every point of the lines the distance is always the same, that lines are called parallel lines. Okay, suppose I have drawn here three lines. These three lines also same. If we extend all of them, they cannot extend each other. Here these lines are not straight, but we have to draw straight lines. Okay, so these lines are not straight as I have not used any ruler here. So that's why these are not straight. So if we draw straight lines and they cannot, if we extend them, they cannot intersect each other. That's why these three lines are also parallel to each other. Okay, and these are perpendicular lines. Perpendicular lines are intersecting each other at a point and also they are making 90-degree angles. That is the definition of parallel lines and perpendicular lines. Okay. Now in exercise 66, few sums are there. In exercise 66, few sums are there. Question number 1 is tick the pair of parallel lines in the following, which are very easy. And also in question number 2, tick the perpendicular lines in the following, which are also very easy. So that will be your homework. As you are learning this for the first time, that will be your homework. If you cannot understand, then you can call me. Okay. Question number 3 again you don't need to do. Question number 4 only I am doing. Okay. True, false. Two lines in a plane are either intersecting or parallel. Okay. Two lines, if they are in a plane, then they are either parallel or intersecting. If they are in a plane. But if it is not mentioned that they are in a plane, then it is not true that they will be either intersecting or parallel. Okay, so here it is mentioned that they are in a plane, so it will be they will be either intersecting or parallel, so it's true. Question number 4A is a true statement. Next one is two lines are either intersecting or parallel. Just now I have told you that if it is not mentioned that in a plane, so it cannot be true always. So it's a false statement that two lines are always either two lines are either intersecting or parallel. Okay, so it's a false statement. Next one, two lines formed by two perpendicular segments are also perpendicular. Yes, that is true, that two lines formed by two perpendicular segments are also perpendicular. So that is a true statement. Next, two segments in a plane are either parallel or perpendicular. Here it is asked two segments, not two lines. So it's a false statement. Okay, two segments are either perpendicular or parallel, not segments. Lines are either perpendicular or parallel in a plane, but not segments. So it's a false statement. Next, question number E. Two perpendicular lines are same distance apart. Two perpendicular lines are not same distance apart. Two parallel lines are same distance apart. So I have just told you that parallel lines are same distance apart. So it's a false statement in case of perpendicular lines. So it's a false statement. Now last one is F. Two parallel lines are same distance apart. Just now I have told you, yes, two parallel lines are same distance apart. So this is a true statement. Okay. So question number 4 I have done only. The remaining sums means question number 1 and 2 will be your homework. Okay. Now page number 178. Open page number 178. Some pictures are given here. You can see, look at the following pictures. Pictures C and D are open curves. Picture A, B, E, F, G, H and I are closed curves. Open means they are starting from a point and they are not ending at that point. Okay, that means open curve. But if it's starting from a point and also ending at a point, at that point only, so that then they are called a closed curve. Okay, so here you can see C and D, only C and D are not closed, otherwise all of the curves are open. But a simple closed curve, what is the meaning of a simple closed curve? See, what did I say just now? That curve C and D, they are not closed. They are not closed curve. The remaining are closed curves. Okay. Now a simple closed curve is that closed curve which does not cross itself. Okay. That is another definition you need to know. That a simple closed curve is a closed curve which does not cross itself. Okay. Simply meet at the point. Does not cross itself to meet at the point. So you can see in this figure, in these given figures, picture A, picture B, picture G, picture H and picture I, these all are not crossing itself. So these all are simple closed curves. But a picture is there, picture E, which is crossing itself to meet the point from which it has started. Okay, so E is not a simple closed curve. Okay, so what did I say? If a curve, when we draw a curve, if we start from a point and after drawing it and we meet at that point only, so that is called a closed curve. But what is a simple closed curve? Simple closed curve is when we start from a point and meet at that point but without crossing the curve, then that is called a simple closed curve. Okay, so I hope now you understood the difference. Now we will learn about the polygons. Okay, here figure F is also not a simple closed curve. You can see figure F, this figure, two circles are there. That means this one, like 8. So again it's crossing itself to meet at the point. Okay, so this is not again a simple closed curve. Only picture G, H, A, B and I, these are simple closed curves. Okay. Now what are polygon? A simple closed curve made of line segments only is called a polygon. So you all know in the previous classes you learned what are curves and what are line segments. So if we make a closed figure, or we make a closed curve with only line segments, not using any curve, only using line segments, then that closed curve is called a polygon. That means only line segments we will draw like this. This is a polygon. This is a polygon. This is again a polygon. But this is not a polygon. Why? This is a circle. This is made of a curve, not by line segments. If we draw any figure with using line segments only line segments, not any curve, then that is called a polygon. Okay, now we will learn the types of polygon. See, first is given triangle, then quadrilateral. Okay, triangle is tri. By the name you can understand, tri means 3. So it will have 3 line segments in that polygon. If the polygon is having 3 line segments, then it's called a triangle. Okay, next is quadrilateral. Quadrilateral. So what is a quadrilateral? If the polygon is made up of 4 line segments, any 4 line segments of any kind, then that is a quadrilateral. So these are the examples of quadrilateral. I told you that 4 line segments will be there in a quadrilateral. In a triangle there will be 3 line segments. Okay. So in your class only these 2 type of polygons are explained. Many more type of polygons are there which you will learn in the higher classes. Now you have to know that these points in which 2 line segments are meeting are called vertices. The plural form of vertex is vertices, and if you use a single form, then that is vertex, called vertex. So the points in which 2 line segments are meeting are called vertices. Same here in this quadrilateral, these points are called the vertices of the quadrilateral. So what did I say? That only 2 types of polygon you will learn in this class, triangles and quadrilaterals. Okay, now we will learn type of quadrilaterals. Means 4 sides. If it is having a polygon is having 4 line segments, then it is called a quadrilateral. But there are types of quadrilateral. What are those types? First one is a rectangle. You all know that. And the second one is a square. Okay. Another types are there which you will learn in the higher classes. Quadrilateral, another types of quadrilaterals are there. But in this class you will learn rectangle and square only. Okay. So rectangle are the quadrilateral which is having these 4 sides. Now see, the opposite sides of the rectangle are same and also parallel to each other. You can see the opposite sides of a rectangle are same at length, means equal in lengths, and also they are parallel to each other. Same in these 2 sides also. They are equal in length and they are parallel to each other. Okay, that is only for opposite sides in case of rectangle. But if we draw a square, then all the sides of a square are equal to each other. Means all the length of all the sides of a square length of all the sides of a square are same. But in rectangle, the length of opposite sides are same. Okay. Here again the opposite sides are parallel to each other, but the length of all sides of a square are same. Okay. Now you can see if we join these opposite vertices, this vertex and this vertex and this vertex, if we join them, that is called a diagonal of the rectangle. Diagonal. Okay, not in case of rectangle, but in case of anything, any polygon, you will get opposite vertex. If you join, you will get a diagonal. So here again we will get another diagonal. So two diagonals in a rectangle, and also we can get diagonals in the square by joining the opposite vertices. So these are the diagonals of the square. I hope you understood. So these two types of quadrilaterals we have learned in this class. In the higher class we will learn more types of quadrilaterals. Okay. Now next is a circle. This is not properly drawn. It's almost like a circle. Okay, this is not properly done. Okay. So whenever you are drawing a circle, you have to use your compass. Now see, this is called, this one which is in the center, the point which is in the center of the circle is called the center of the circle. Is called the center of the circle. Okay. Now if we join any two points on the circumference of the circle, means on the circle, this is, okay, this circle is made up of a curved line, no? So if we join any two points on this curve, we will get a line. This line is called a chord. Okay. So again I am repeating, this is called the center of a circle. If we join any two points on the curve of the circle, that is called chord. Okay, I told you that this is the curve which is making the circle. So this curve is called the circumference. The total length of the boundary of the circle, okay, that is called the circumference of the circle. This is the circumference that you will learn in the higher classes. Now if we join the center with any point on the circumference of the circle, you can join this point and this point, you can join this point and this point. Center with the point on the circumference, that length is called the radius of the circle. So the length is called the radius of the circle. And if we join any two points on the circumference, but the line is going through the center of the circle, you can see these lines is also made by joining two points on the circumference of the circle, but this line is not going through the center of the circle. That's why this is called a chord only. But if this line which is joining two points on the circumference of the circle, but also is going through the center of the circle, is passing through the center of the circle, that line is called the diameter of the circle. What did I say? The diameter of the circle. Okay, now see, this is another line I have drawn which is joining two points on the circumference of the circle and also which is passing through the center. So this is another diameter. Diameter, whenever you are drawing the diameter, no matter where you are drawing the diameter, the length of the diameter will always be same. Similarly, the length of the radius will always be same. Now you can see this length is called the radius. This length plus this length is called the diameter. So that means radius is half of diameter, or diameter is double or twice of the radius. Okay, so again I am repeating, radius is half of the diameter. Similarly, that means eventually the diameter is twice of the length of the radius. Okay, so this is the two formulas which we will need in doing the sums in the next exercise. So now I am starting exercise 67. Okay. So in exercise 67, question number 1 is, which of the following are simple closed curves? I have told you simple closed curves are the curves which is starting from a point and meeting at the point without crossing itself. So you can see A, the figure A is a simple closed curve, figure B is again a simple closed curve, C is again a simple closed curve, D is not a closed curve. See, figure D is not a closed curve, figure E is not a simple closed curve. Figure F is a simple closed curve, G is crossing itself, so it's not a simple closed curve, H is again not a closed curve only, I is again not a simple closed curve, okay, because it's crossing itself, so I is not simple closed curve. In question number 2, which of the following are polygons? So you can see first one is made of a curve and a line. So I have told you polygons are the figure which are made up of only line segments. So this question the figure A is not a polygon. B is again not a polygon, it's made up of a curve. C is a polygon, D polygon, E polygon, F is not a polygon, G is a polygon, H is a polygon, I is not a polygon. Okay. Question number 3, which of the following polygons are triangles? Triangles are 3 sides. So you can see only figure B and figure D are triangles. In question number 4, which of the following polygons are quadrilateral? So quadrilateral means 4 sides. So only figure A and figure E are quadrilaterals. Next, question number 5, in the figure ABCD is a quadrilateral in which AB equals to CD, BC equals to AD. What the other name you can give in this to this quadrilateral? Opposite sides are same, and you can also see the picture. So it's a rectangle. I have just told you the definition of rectangle. So opposite sides are same in length. That's why it's a rectangle. In question number 6, in the figure PQR is a rectangle, name of a rectangle. So write down the name of opposite sides, opposite vertices and diagonals. So I am writing here in question number 6. First, the opposite sides I am writing here. PS and QR, these are two opposite sides, and another set of opposite sides are RS and PQ. These are two opposite sides. This is A. Now B is opposite vertices. So S and Q. SQ are opposite vertices and RP or PR are opposite vertices. C is diagonals. Diagonals are SQ and PR. These are two diagonals. Okay. Now next question number 7 is, in the figure PQRS is a quadrilateral in which PQRS, QR and PS all are same in length. So what type of quadrilateral is it? Measure them and are they equal? You have to measure by yourself in the book. I am just telling what is the name of this quadrilateral. You know, if all sides are same in length, then it's a square. Okay. Now question number 8. In the figure, name the parts of the circle: center, chord, radius and diameter. I have told you the definition of these all. So that will be your homework. You have to name the center, the chord, the radius and the diameter of the circle. Now question number 9 is next. The radius of the circles are given, find the diameter. So I have told you that radius, the length of the radius is half of the length of the diameter. So here the radius are given, we have to find out the diameter. Diameter is twice the radius. So by multiplying 2 with the radius, we can get the diameter. But before doing this one, we have to write the formula. That diameter equals to, what is the formula we will write? Diameter equals to 2 into radius. So here we are finding out the diameter. Radius is given. In the first question, radius is given 8 centimeter. So 2 into 8 centimeter, it will be 16 centimeter. So first you will write the formula that diameter equals to 2 into radius. So diameter equals to 2 into 8, that is 16 centimeter. Okay. in question number B, that is A, that was A. Question number B, 10 is the radius, so 10 into 2, 20 will be the diameter. This way you can find out all the diameters. Now in question number 10, find the radius of the following circles, their diameters are given. So here the diameters are given, we have to find out the radius. Another formula we will write here. What will we write? We will now write radius equals to, in the previous one we have written here that diameter equals to, now radius equals to diameter by 2. Diameter divided by 2 is radius. So what is diameter given? Or you can write in this way also, diameter divided by 2. Okay. So the diameter is 20 centimeter divided by 2 centimeter. So it's 10 centimeter. In question number 10's A, the radius is 10 centimeter. In the next question also, 12 by 2, 6 centimeter will be the radius. This way you can do the remaining ones. Now we will do question number 11. Say whether the following statements are true or false. Okay. So first one is, a vertex has a triangle has 3 sides. So it's a true statement. Okay. Next, a quadrilateral is a simple closed curve. Yes, it's a simple closed curve. So again, it's true statement. Next, the radius of a circle is twice its diameter. No, the diameter is twice of its radius. So it's a false statement. Next is, a square is a polygon. A square is a polygon, so it's a true statement. Yes, a square is a polygon because it's made up of line segments only. Next, diameter of a circle is also a chord. Yes, definitely diameter of a circle is also a chord, but it's passing through the center only. So it's again true. Last one, a triangle has 4 vertices. No, a triangle has 3 vertices. So it's a false statement. Okay, done. Now next is question number 12. Fill in the blanks. The point where 2 sides of a square meet is called a vertex. I have told you 2 lines are meeting at a point in a square or a rectangle are called vertex. Also in a triangle. Also in every polygons. Okay. Now B is a quadrilateral has 4 sides. So it will be 4. Next, in a rectangle, the dashed sides are equal. I have told you in rectangle, opposite sides are equal. So in a rectangle, the opposite sides are equal. Next one, a triangle is a polygon having dashed sides. Triangle is having 3 sides. Last one, all quadrilaterals are dash squares. All quadrilaterals are not squares. Okay, are not squares. So up to question number E is there. 3. Okay. So up to question number 12 you have to do. Question number 13 and 14 you don't need to do from this exercise. So I hope you understood these 2 exercises because these are very easy exercises. This exercise 67 is a little bit long, but exercise 66 only 1 question I have done from there. So I hope you understood these all sums. If you have any confusion, then you can call me anytime. Okay. So till the next video, take care and bye.